Okie dokie, music by Lo-Fi Girl. Please don't disable my video. This is gonna be an interesting video because we got it to work, the hero list that is, but we're trying to get it to run on a different clean machine because currently when you run the dedicated slave on one machine, if you try to run a client at the same time joined to the slave, it performs very poorly. Another thing that's pretty cool is I'm gonna try something because usually I can't just talk and work at the same time. There's this cool little AI text-to-voice creator that can use your own voice, and I'm gonna make a script here and play it for you. I'm still gonna be here in case anybody joins or has any questions, but this script is going to is gonna read everything off that I've kind of been doing in a much more organized way than I can do when I'm actively trying to work, just to make these live streams a little bit more interesting. It's pretty cool. This Chatterbox GUI, I made it so I didn't have to use Chatterbox in a command line interface. I wanted it to be really easy for me. And so now we're gonna listen to about what the yep, here you go.
Machines. Okay, so right now what we're doing is taking Thorgor from being something that works on my development PC and turning it into something that can actually work on another machine without that machine already having all of my development history on it. And this exposed something kind of important. The build itself worked. The problem was that my dev PC had been patched incrementally over time, so I had gone through multiple K2 DLL revisions while developing this thing. V57, then V65, then later builds like V75, V76, and finally the current V77 build. So when I ran the V77 launcher on my development machine, everything worked because the DLL underneath it was already in a state that V77 expected. But when I copied the exact same Thorgor folder to another computer and tried to run it, it failed. At first it failed with this really weird Windows batch error. Heroes was unexpected at this time, which looked completely unrelated to anything. But it was actually because the remote computer had Heroes of Newer installed in program files x86. So the path was program files x86 Heroes of Newer. And because Windows batch files treat parentheses as syntax, one of the lines in the launcher was expanding that path inside an if statement without protecting it correctly. So the x86 parentheses were basically breaking the batch parser. That part was easy enough to fix. Once that was fixed, we got farther. And then we hit the more interesting problem. The V77 patcher looked at the remote machine's K2.dll and refused to patch it, which is actually good. The patcher checked SHA-256 hashes before modifying the DLL. It doesn't just assume the offsets are correct and start writing bytes into an arbitrary K2.dll, because doing that would be an excellent way to just corrupt the game.
Agreed.
The remote machine had this K2 hash 6F5FC1F7BF4 EO1CDEB036XT70329.
I shouldn't have put that in the script. Blah 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 blah. Good lord.
4FT96 random or incompatible DLL.
Okay.
That hash was actually one of our own previous builds, K2V57. So suddenly the problem made sense. The V77 installer expected something like V65, V75, or V76 as its starting point. My development computer already had that history. The other computer didn't. So now we're fixing the installer itself instead of manually fixing every computer. The new idea is that Thorgor should understand the entire upgrade chain. A fresh Heroes of Newer 3.2.7 install should be able to start at the original K2 DLL and automatically move through the versions required to reach the current build. So, conceptually, stock K2 to V57, to V65, to V77, and if the machine already has V57, it just starts there. If it already has V65, it skips straight ahead. if it has v75 or v76, v77 already knows how to patch those. And if it already has v77, it should just verify the hash and do nothing. Same idea for keygain.dll. We're currently using kbeef61, so the installer verifies and installs that independently as well. This is actually a pretty significant difference in how the project is deployed. Before this, Thorgor worked partly because my development machine contained months of accumulated state, files had already been patched. Earlier revisions had already been installed. Certain assumptions were just true because I'd been developing on the same machine the entire time. That's fine during development, but it's terrible for deployment. Because somebody should not need to recreate my development history just to run the server package should create the required state itself. So the goal now is basically this. Take a clean Windows machine, install Heroes of Newer 3.2.7, copy Thorgor onto it, run one update script. Thorgor determines what DLL revision is currently installed. It verifies the SHA-256 hash. It applies only the required hash stages. It verifies the final output, and then the current v7 server stack can launch. That means we're moving away from this works on my computer and toward this build knows how to turn another compatible computer into the same environment, which is obviously what we need if Thorgor is ever going to be more than a development experiment. We're also keeping the patching conservative. If the installer encounters a DLL hash that it genuinely doesn't recognize, it stops. It does not blindly patch it, because these are binary patches. We're modifying specific machine code locations inside K2 and Cgame. The source binary matters. The expected bytes matter. The offsets matter. So an unknown binary should fail loudly instead of becoming some mystery corrupted DLL. The other thing we found while building this chain was a smaller scripting problem. Some of the older patch scripts used exit 0 when they detected that their version was already installed. That makes sense when you run the patch script by itself, but once we're chaining patchers together, that becomes a problem. Because v65 might call the v57 patcher first. And if v57 sees that v57 is already installed and calls exit, it can terminate the entire parent PowerShell process, meaning we never continue to v65. So those early exits had to become returns. Small change, but exactly the kind of thing that only becomes obvious when you stop treating each patcher as an isolated development tool and start treating the whole thing as an actual installer. And that's basically where we are now. Thorgor v7 itself is working on the development PC. The hero state work is functioning. The current task isn't really reverse engineering the game anymore. It's deployment engineering. We're taking all these discoveries and patches we've accumulated and packaging them so another machine can reproduce the known good environment automatically. Once this works cleanly on the second computer, that's a really useful milestone, because then the project is no longer dependent on the exact history of my development machine. It's a reproducible build, and that is a much bigger deal than just copying a folder and hoping it works.
I couldn't have said it better myself. It's a lot to go over. I mean, it's impossible for me to develop and talk about how I'm developing at the same time. I can only talk about it retrospectively or have, AI give me a review of the hours of work we just did. Having said that, I kind of expected this to run out, so we've actually got another audio file to go over the fixes that we did this morning. So this will now tell you about that and how we got the hero list fixed.
This morning we finally fixed one of the longest running problems in Project Thorgor. The problem was the hero selection screen. The host player could enter hero selection normally. The hero portraits were there, heroes could be selected, and everything looked basically correct. But when another player joined the same game, that second client would reach hero selection and the hero list would not initialize correctly. Instead of the normal portraits, the client would get generic placeholder images. For a while I thought this might have been a problem directly inside the hero selection code, There is logic in Heroes of Newerth that decides which heroes should be visible, which heroes are banned, which heroes have already been selected, and which heroes a player is allowed to choose. So it made sense to suspect that the second client was somehow getting filtered incorrectly. But the actual problem turned out to be lower level than that. The hero list itself was not really broken. The second client was not receiving the complete game state that the hero list depended on. Thorgor had already been modified so multiple clients could connect through code that originally expected a much simpler client structure. That got us surprisingly far. Both players could authenticate. Both players could connect. Both players could enter the lobby. Both players could even reach hero selection. But reaching the screen did not mean both clients had received the same internal state. That distinction ended up being the important part. The original game has a normal path for delivering game state to the first client. I started referring to that player as the head client. Then Thorgor has additional link clients behind that first client. Those are the extra players that we added through the multiplayer patches. The second player was effectively sitting at the tail of that linked client structure, and that tail recipient was not being synchronized the same way as the original head client. That is where version 77 came from. Instead of replacing the original game state handling, the new patch preserves the stock behavior for the head client. That was important because the original path already worked. There was no reason to break the working player while trying to fix the second one. The patch then separately handles the remaining link clients. For those clients, Thorgor reconciles the important game state blocks, specifically blocks 3 through 8. Those state blocks contain part of the information the join client needs while transitioning into the actual game session. The fix delivers those blocks to the additional linked clients using the game's existing guarded queue behavior. That was another important change. An earlier experiment tried injecting state through the network more directly. That approach was disabled. Instead, version 77 stays much closer to the way K2 already expects game state to move internally. So now the sequence is much cleaner. The original head client keeps using the original callback and queue behavior. The additional clients are walked separately. Each remaining link client receives a state it was previously missing, and the snapshot sequence stays synchronized instead of us trying to manufacture network traffic outside the normal path. Once that happened, the remote client's hero selection screen suddenly had the information it needed. The placeholder portraits disappeared. The actual hero portraits rendered, and the second player could see the same hero selection state that the host could see. That was the big realization. We did not really fix the pictures. We fixed the state synchronization underneath the pictures. The broken hero list was just the visible symptom. C-Game was already doing what it was supposed to do once it had the correct information. The important fix was inside the K2 multiplayer modifications and how game state was delivered to the additional recipient. That is also why this bug survived for so long. From the outside, it looked like a user interface problem. Then it looked like a hero filtering problem. Then maybe an entitlement problem. But the actual failure was further down in the multiplayer state delivery that Thorgor had modified. And because the second client was connected and technically inside the game, it was easy to assume synchronization was already complete. It wasn't. This morning, that final missing part became visible. Preserve the working head client behavior. Walk the additional linked clients. Reconcile the required state blocks. Put them through the guarded K2 queue. And stop trying to inject the state outside the normal system. That became the version 77 tail recipient hero fix, and for the first time the non-host client entered hero selection with the real hero list properly rendered, which means another piece of the original Heroes of Newerth multiplayer system has now been reconstructed well enough to work through Thorgor.
Okay, couldn't have said it better myself. We're gonna go to the next script in a second. This is all just, I can't describe the work as well as a AI reviewer can. It's too much. Yeah, and we're still working right now, so I'm still trying to get this to be deployable. And I'd rather some of these videos have a little bit of information about how the code works rather than just make it work. It's not working, and then I turn off the stream and do a bunch of work that makes it work, and then it's not captured. So, yep, that's what these narrations are for during this. I do want the information to be shown and understood, because this is not just I mean, it's completely AI assisted. I'll admit that. It's 100% without AI. I wouldn't be working on this. Having said that, I don't think it's slop. I don't think it's crap. I don't think it's useless either, because this is the only version of this that currently exists. You can't, even the open source project Kongor is for a later release of the game. So if you wanted to go back into this version, you couldn't. If the people who are the proper computer science, reverse the whatever. I'm just one person doing this for fun, for a thought experiment to see if I can. And so far it's been. You don't really know if you're making progress until you get there. Yesterday was just spent a bunch of credits on trying to fix the hero list, and then on one final prompt before I went to bed, I stated the problem again. I expected to wake up and have the problem still there, but the problem wasn't there. So now we're gonna go over how Ghidra, I think that's actually how it's pronounced, or Ghidra, whatever, and Cheat Engine were used to read the binaries in memory and in decompiled states, so that we could reverse engineer the protocols so that we could make our own server. Because that's what this is. This is not just like a hot-wired crap version of the game that's like that you could just do if you ran something in command line. No, this is a massive project at this point. And it's finally to the point where you can play LAN games properly. And so I just need to get it deployable on clean machines, which I've done before, but we've gone through about 20 different versions since the last publish to GitHub, because I only published the milestones, and so it's having to refactor and do a lot of work to make sure the patches to the DLLs happen in the right order, because it's going to patch them sequentially based off of what we did. So yeah, now we're going to talk about Cheat Engine.
A big part of getting Project Orgor to this point was using Cheat Engine and Ghidra together. They serve two very different purposes. Ghidra let us understand the game while it was sitting still. Cheat Engine let us watch the game while it was actually running, and the combination of those two tools is what slowly turned the hero list problem from a vague client-side bug into something we could actually explain. Ghidra was our map. We loaded the original heroes and North libraries into Ghidra and started following the game's assembly and decompiled code. The goal was not just to randomly patch instructions until something worked. We wanted to understand the original multiplayer logic. We looked for functions involved in clients joining, game state updates, snapshots, player structures, and the paths that moved information from the server into the connected clients. Ghidra was especially useful because it let us move outward from interesting functions. If one function called another function, we could follow it. If a value was being checked before a packet or state block was sent, we could follow that decision. If a function referenced a client structure, we could look at how that structure was being used in other parts of the game. That slowly gave us a picture of the original architecture. But static analysis has a limitation. You can look at assembly for hours and still not know which path the game is actually taking during the exact failure you care about. That is where Cheat Engine became important. We attached Cheat Engine to the running game and dedicated server and started placing breakpoints on instructions that Ghidra had identified as interesting. Then we reproduced the bug. Start the server, join with the first client, join with the second client. Watch what actually executes. That let us answer questions that were almost impossible to answer just by staring at the disassembly. Does this function run when the remote player joins? Does it run only for the host? Does the second client ever reach this call? What object is being passed into it? Does the pointer belong to the first client or the second client? What changes in memory when another player enters the lobby? At one point, we were even manually following pointers from memory and comparing the client-side data between the working and broken cases. That kind of testing was tedious, but it mattered, because every time a breakpoint did not trigger, that was information too. If we expected some hero selection function to execute for the second player and it never did, then our assumption about where the failure occurred was probably wrong, and that happened several times. The visible problem was the hero portraits. So naturally, we spent time looking around hero selection logic. There was code for heroes being selected, code for banned heroes, code for hiding heroes that were already taken. All of that looked suspicious. It was completely reasonable to think the second player was reaching the hero screen and then getting every hero filtered out, but Cheat Engine kept showing us that the problem was not behaving like a simple rendering failure. The client was missing something earlier. The deeper we went, the more the problem started looking like incomplete state synchronization. This is where Ghidra and Cheat Engine started feeding information back into each other. We would identify a function in Ghidra, then test it live with Cheat Engine. The runtime behavior would tell us whether we were looking in the right place. Then we would return to Ghidra with a better idea of what the function actually represented. That process repeated over and over. Eventually, we started understanding the client structure itself. The original game was built around assumptions that Thorgor had already changed. Thorgor had modified parts of the game so that more than one real player could exist in situations where the old code expected a much simpler arrangement. That is how we got the second player as far as we did. But it also created a new problem. Some of the original code still behaved as though there was one important client at the front of the structure. The first player went through the normal game state path. The additional player existed behind that first client in the link structure. Cheat Engine helped us see the runtime consequences of that. Ghidra helped us understand why. The second client was connected. The lobby knew the player existed. The game could transition that player surprisingly far, but some of the state delivery logic was still effectively stopping after handling the original recipient. That explained an enormous amount of weird behavior. It explained how a player could technically join a game but still have incomplete information. It explained how the lobby could look mostly correct while hero selection was broken, and it explained why fixing the user interface directly would have been treating the symptom instead of the cause. Once we understood that, the patching strategy changed. Instead of asking how to make the hero portraits appear, we started asking a much better question. Where does the working client receive the state that the broken client never receives? Ghidra gave us the code path. Cheat Engine let us verify that behavior while the game was running. Then we could modify the libraries, launch another test, and immediately see whether the second client moved closer to the behavior of the first client. Some attempts failed. Some patches caused crashes. Some paths turned out to be unrelated. There were places where we expected a breakpoint and got nothing. There were places where a pointer looked promising and then turned out to be the wrong object. But every failed test narrowed the search area. Eventually, the evidence pointed toward the game state queue and the way additional link clients were being handled. The important realization was that the original path of the first client was already good. We did not need to...
Okay, take a pause there, AI Thor. We're gonna do some manual stuff now. And that is, can we get the goddamn thing to work? Let's see. Oh, that was closed. Let's see if we can get the goddamn thing to work. So, we're gonna... Oop, I don't even think that looks right. That doesn't look right to me. Get rid of all that stuff. Alright, sure. Just give us a new line. Okay, what'd it do now? Oh, hell yeah. Oh, hell yeah. Okay, cool. If that all comes up, then that needs to be put on the repo. Oh, hell yeah. Oh, hell yeah. That's very good. We were not getting this before. Let me turn up the music a little bit now. Cool. Well, actually, when that gets going, I'm gonna run the next test, which is gonna be Oh, this is awesome. So check this out. Because that's running on a different computer, and it has to right now, because if you run it on the same computer as you're trying to run the game, it doesn't behave well. And I don't blame it. You know, I think that's reasonable. So we should be able to go and start the remote player now. Look at that, it came up. Everything worked on the deployment computer, or whatever the computer we deployed it to. So now let's see if it's actually serving it. 158, I believe, is the server. Let's see, creating and install. Oh, that's so awesome how it does these checks. I wonder if I need to update that folder, actually. Well, we'll see in a minute here. So let's log in as player 2 won't work because, oh, that's good. Oops, did not mean to open Chrome. So this is a good chance to show Jesus Christ, the other features. So this downloads to your user profile if you just run PowerShell from nothing, but you can actually do, there's an account manager that you can run. So if we look at the accounts, there's only Boner. Let's set a couple accounts. Let's do player. Set another one, player 2. And now if we list them, we'll see that we've got player 2, Boner, and whatever. So that's good. So now when we go into login, if we log in as player and the password is player, hey, lets us in. So we can go here, we can create a game, should be able to find a server. We found a server. We're going to change it into, this is fine. So that usually takes a little bit of a second. While that's going, I'm going to start up another remote player. Let's see. Oh, that's funny. It doesn't like that. What if we start local player? Okay, I think that might work. So we are logged in as player, and in a moment the second client should be popping up here. Yep, there it is. And we're gonna sign into somebody else. There is no user concurrency checks right now because I am still developing it, but it's at a place where I want to deploy it for you guys, because look, the test game shows up. And this does work over LAN because the server is not on this computer that I'm testing it on. So if you ran the same executable, you should be able to run 2 different clients or more. And I'm going to see if there's a way to containerize the dedicated slave, because I don't think it's a resource issue for the slave and the client running. I think it's more like a software interference deal, because what we're about to see is pretty cool. Look at this. Both of the hero lists show up now. And so if we go and pick Swiftblade, on the other one, Swiftblade is taken. And let's go Grinix. Let's go ahead and ready for both of them. And I'll just I mean, that was the big hump we were trying to get over yesterday. It was that the hero list didn't show for everybody. And so on a computer that is not running it, you can see the performance is excellent. If I tried running the slave on the computer that I am playing the game on, it does not go very well. But I think that still might be natural behavior, because when S2 hosted this, I don't really think they would put the dedicated slave on a computer that is running the graphical client. It doesn't really, if that might be true, but I feel like when they deployed it and had it running, they never had it set up for that case, because it's not as stable or safe that way. But so that is what we've got right now. I need to double check and make sure the GitHub one-liner works as well. So we're just gonna get out of these and stop the server. Let's see, get out of this, Get out of this. And then, yep, it's closed. So, the next thing I want to check is, does the one-liner on my GitHub still work? Let's see. Let's just test it this way. By just looking at it. When was it updated? Oh wait, 2 branches, frozen working. Wait a minute. There we go. Okay, those are not the same. That's fine. Let's just have this updated. And while that's going, we'll listen to some more of the explanations.
Reinvent it. We needed to preserve it. Then we needed to extend the same state delivery concept to the additional recipients Thorgor had introduced. That became the basis of the tail recipient fix. The first client continues through the normal path. Thorgor then walks the additional linked clients and makes sure the required game state reaches them too. And once that underlying state was present, the hero list started working. That is really the role Cheat Engine and Ghidra played in this project. Ghidra gave us structure. Cheat Engine gave us evidence. Ghidra showed us what the code could do. Cheat Engine showed us what the code was actually doing, and by going back and forth between the two, we stopped guessing based on what was visible on the screen. The hero portraits were the symptom. The real bug was buried several layers underneath them. Without Ghidra, finding that code path would have been mostly blind. Without Cheat Engine, we could have spent days confidently studying the wrong code. Together, they let us follow the problem from a broken hero screen, through the client structures, into the multiplayer state handling, and finally, to the missing state delivery that version 77 corrected. That is how we got from a second player crashing and seeing broken hero selection to a remote client actually receiving the state required to render the real hero list. This morning we finally fixed one of the longest running problems in Project Thorgor. The problem was the hero selection screen. The host player could enter...
Okay, sorry about that. Looks like it was set on repeat. I think that's enough of that. It's getting a little repetitive. Basically, yeah, I used some tools and pasted the output and asked for directions and reverse engineered the game. TLDR. What I'm doing is cleaning up this this one because we're gonna deploy to this one and make sure that basically it works. So I have to reset it just like how it would be for somebody else if they wanted to download this package. So we're just gonna install the game clean to make sure everything's fresh. So we should see the files that I need to patch seen here at some point. K2 DLL and C game DLL. Alright, we got Heroes of Newerth again, and it's cleaned up this time. Well, actually, let's clean it up even more. Because I see that it still left some files in there. Because I want the deployment process to be the same for everybody. So yeah, there's still a bunch of stuff in here. So I need to get rid of that. Okay, let's go ahead and reinstall now. It says that it was updated. Let's verify that. It should say that a commit was pushed like a minute ago. Yeah, cool. Let's see if it's working on the home server first, just to make sure. Looks like it is. That's awesome. How did it get all of that up so quick? That is nuts. Yep, just want to make sure that it's working here. Okay, well that's cool. It seems to have fixed that. We're probably going to commit this to main in a second because it's working. Alright, let's install the client new. And I think the easiest way to patch your game is to just run that one-liner deployment on client machines. You can close the server afterwards, but I think it is potentially the easiest way. However, let me see. Remote client has start remote player, so probably still have to put those into, well, let's see. Oh, you know, I think you can just run those from anywhere. Never mind. Okay. So HoN's installed again. We're going to take this one-liner and run it on the clean machine that has not had anything. Let's see. Because it looks like the one-liner is good. Okay, so let's start up PowerShell on this computer. Oops. Got too many computers I'm inside of. Alright, we're going to start PowerShell. We're going to run the one-liner, which is supposed to acquire and install and run it all in one step. Oh boy. That's fine. Let's go and grab it from here if I have to. Come on, slow laptop. Nothing like this Ryzen computer. Alright, let's see. Oh, gotta go to the right branch. Frozen working, version 77. Holy shit, been working on this for a while. Okay. Now we've got it copied. Let's try running it. Oh, looks like it's working. Oh, sick. It's updating all the DLLs and it's running the server first try. Now, that's not what I actually want to see. I don't care about that running the server. This one running the server is good, because what we're about to test is the LAN function. So let's go here and find our folder and run the remote client and see if we can start this. Okay, and so we're going to start a remote player as well here. Enter in the IP address. Oh, this is awesome. I think we're just about to the point where it's deployed. Actually, it might be. I think I want to clean up some of the files in there at some point, but we'll commit this to main. So that's player 2. Let's log in as player. Okay. Let's go ahead and make sure. So we've got 3 machines in the works right now. We've got this computer, the dev machine, and then on here, whoops, where am I at? On over here, we have the server that is hosting it. On here is a client, and then on my computer is also a client. So I'm gonna go ahead and create the game. Usually hangs for a little second after you create game. If you get bored, you can click the button again. Nothing really happens. But then now on the client, we don't want this. On the client, we can see the test game is in there. And so we'll join a slot on my computer, and then we'll join this game on the other one. And we'll see that they're joining. And actually, I think I can run as many clients as I want to test up to 10 people. I have to try up to 10 clients. But now, okay, we start the game. The game is started. We're both joined in here. And check this out. Gee, sorry for that. Oh God, sorry for that. That is so loud. Jesus, I am so sorry about that. Okay. Well, basically the hero list now shows on both of them. And these are on, this is over LAN. So you can play Heroes of Newerth 3.2.7 over LAN if you'd like to. Just download run my one-liner after you get Git and Python installed. And the game works. The game works over LAN very well. So yeah, for now I think I'll keep working for a little bit, but we are at a very good break point, because the next thing I want to do is just kind of clean up the repository and commit it to main. Let's see. Well, I think that's it for this live stream. I think I'm going to make a video later today on how to deploy this yourself and play it yourself. Because it seems to be working now good enough that you can at least do a LAN 1v1, provided you have a third computer to host it on, which isn't a crazy requirement, but it is. You need more than 2 computers to play a 2v2 because one needs to serve the game, which I have not even started looking into because I think that might be natural behavior for the game. I don't know if they intended the dedicated slave to be running on the same Windows instance as a client. I'm not sure that was intended. But yeah, thank you for watching after the fact or if you tuned in, and I hope you have a good one.